So we'll have three discussants. First, we'll have Bentley McLeod, the Samim Nemne Professor Emeritus of Economics in our Department of Economics here at Columbia. Suresh Naidu, Jack Wang and Echo Ren Professor of Economics, who is also a Professor of International and Public Affairs. And then finally, Joe Stiglitz, Nobel Laureate in Economics, university professor with appointments in the Department of Economics, the Business School, and the School of International and Public Affairs. And Bentley will be our first discussant.
How do I do the slides?
They magically appear.
Oh, I see. All right. Well, thank you very much. Thank you for inviting me to comment on this for this incredibly distinguished panel. I mean, the first thing is I enjoy commenting on the brilliant work of Susan Athey. Her productivity sort of reminds me of our dear colleague Joe Stiglitz. So they're sort of in the same league of being incredibly productive. Each paper in this talk actually deserves a long discussion, which I don't have time to. So instead, I think Mike Wood sort of asked me to talk about AI and machine learning or the digital economy more generally for labor markets. And so what I'm going to do is I'm going to talk about the good, the bad, and the ugly. Okay? And in brief, the good is actually going to be Susan's work, and then the bad and the ugly are going to talk about aspects of machine learning and AI that are relevant for labor economics. And in some sense, the reason I'm discussing this is also to serve prime students out there on topics to be addressed. And these are going to be questions that are serious questions, but not currently being well addressed with the current technologies. In particular, what we'll see is that Susan's work is going to provide some very useful tools to understand current labor market issues, but there are going to be some issues raised by these new technologies that I want to talk about as well, that I think we should worthwhile thinking about. The good, the immediate benefits of AI. So first thing to keep in mind is that AI has, all of us are using ChatGPT. It's arrived very quickly. So the red dot here is a paper by a recent paper on the dangers of AI. And it's only one dot because it's so new, but you can see the red dot's above the green line and the yellow line at the beginning. The green line is basically the rise of internet usage in the economy. The orange line is sort of the use of computers, and the AI is sort of higher. And so what we can expect here, if the future is any guide, is that red line is going to continue at a higher rate of adoption than internet or computer use. And that, for a lot of people, that's concerning, and there's been a lot of concern about this. But before I talk about the concerns, let me talk about use this to put Susan's work in context. So we had sort of 5 papers. Each one of them deserve a long discussion, so I don't have time to do that. So the Athey, Simon-Sands, Vikram, Jokamovich paper used a machine learning algorithm to detail the cost of job loss. So what I'm going to do here is I'm going to break up in sort of 2 parts. One part is how these techniques are very useful to describe what we see in the labor market, and the second part is what we can do are policies actually improve matters. And so in this machine learning algorithm, what they're able to do is basically look at the cost of job loss based by worker characteristics, and the benefit of studies to assist in the design of more efficient targeting of harmed workers. In this particular case, they found that older workers in routine tasks were particularly harmed by job loss. The next 2 papers are Athey, Brunberg, Du, Kanaura, and Vafa introduce the career model to assess the role of job histories on labor market outcomes. The allocation of process for workers is very complex and poorly understood. And I think one thing to keep in mind, even as labor economists, we're just basically scratched the surface of this complicated system. The labor market is millions of individuals that are getting matched every period. It's a very complex process. And I think what's exciting about this work is to take these very complex process and be able to say something sensible about how worker job matching has occurred. And then what they use this model for an actual practical application of getting better estimates of the gender wage gap. So I think this is really exciting work, and I think could potentially help us understand complex phenomena. And then the final 2 papers are basically experimental evidence on how online services, or I would say the digital economy, can help and improve labor market models. So these are very practical solutions that can help people today. I got 5 minutes left. I've got this red thing. Have I used that much time? Okay, the bad. So I want 2 things about the bad. The first bad is one thing that we don't do very well is the modeling of expectations. So there's a really neat paper by Kovundis, Chai, Lang, and Malhotra that basically looks at the effect of expectations on labor supply. In this particular graph, we look at the fraction of workers by age that are truck drivers. And what you can see in 2006, between ages 35 and 45, there are, more than 4.5% of workers were truck drivers. Very important job. As you can see, in 2020, it's dropped dramatically. Truck drivers are saying, look, why would I want to become a truck driver when we're soon going to have this self-driving trucks? The interesting point is their behavior is being pushed by expectations, but we still don't have self-driving trucks today. So in a sense, there's an issue of how do we, in some sense, match what's actually going to happen with their expectations. But what we can see empirically is just the threat of AI is causing people to adjust their behaviors in the labor market in ways that are actually difficult to anticipate. So that's what they show here. So more generally, all jobs require some relationship-specific investments, and hence job choice depends on future expectations. So in the examples that Susan was pointing out, these are very short-run types of jobs. But when you're thinking of your career, should I become an economist or go into computer science or some other area, I'm looking at doing an investment today that's kind of a 30 or 40-year horizon. So a big open question is how are these new technologies going to affect these long-run returns? Current AI models, even though they're really cool, they're retrospective. They're taking existing data sets, your text that you write, they do non-structural inference of existing data, hence by construction, they're not forward-looking. So the good news on that is all of you as economists have a job to do. How do we construct models on how do we predict what's going to be the future outcomes? This problem is well recognized, and many people in the AI area I've talked about this and worried about what the impact of AI is going to be for the future. And there's this study by Bengio in 2025 that I got some of these graphs from. Let me go to what I think is sort of the final point, the ugly, the impact of AI and the meaning of work. And I think this is a very serious problem. The paradigm labor market model builds on the classic algebra model that assumes that work is only valuable for the income it produces. It's a useful model, a good way to start, but given that we spend much of our life at work, we clearly value the time at work. All of us here who are academics, we enjoy our jobs, we like being on those jobs. The issue then is and I remember listening to somebody say, oh yeah, we're soon going to have Einstein in your pocket. So there's a program called Yoke AI. It's your secret study weapon to ace any topic, any school exam, any standardized test. It's like having Einstein and AI in your pocket. Well, you can easily, the next step is, look, if I got Einstein in my pocket, why do I even need to take these tests? Einstein in my pocket can actually take these jobs, right? And so then what you have a situation is that being Einstein or being Joe Stiglitz is a great job, right? Are we going to have no more future Joe Stiglitz? I mean, that's the question we should be asking ourselves. And I think one of the ways we can see this empirically, if you look at this graph, this is basically different areas of study, and we're looking at how quickly this is catching up to the human level of performance. So the red line is reading handwriting. We're basically in 2016, we can read handwriting. The orange line is image classification. Then we have a couple of image classification. We have basic level reading is the green line. The blue line is basic English language understanding. I guess it's teal. The other blue line is multitask language understanding. Then we have general problem solving is sort of the purple line, and then we have PhD level science questions. So what this is sort of illustrating is that these AI tools are going to take our jobs. And it's something we should actually worry about. And in fact, you think, well, maybe that's a little bit, do I have any evidence to worry about this? Well, we do have some. AI is certainly increasing our productivity. When I did these slides, I now use LaTeX is much easier for me to use. Since I'm a little bit ADD, I make lots of coding errors, but now with AI, I can code more quickly. But we have to remember, how do we evaluate changes when AI replaces the activities that humans find very rewarding? The question is related to growing literature on dignity at work. Hodgson has a nice book describing the various ways by which we get value from the jobs that we have. Dubé, Nadeau, and Reich, Nadeau here, provides a good start on how we begin to measure the importance of work as a consumption good. More ominous is the recent evidence, we actually have evidence showing that AI tools increase research productivity at a material science group at the cost of lower job satisfaction. There's a paper by Toner Rogers at MIT. It's a fantastic paper, and what he shows is that while AI made workers more productive, they're less happy, right? And that's, I think, in some sense, what we have is Susan Anthony has started an important agenda on the use of AI and machine learning tools to understand and improve labor markets. It's an exciting agenda with many open questions. How will labor markets adopt and evolve over time? How should we evaluate the impact that these changes will have on worker well-being? And how will AI impact impact the welfare of our most skilled workers. And I'll stop there. Time is out.
All right, thanks a lot, Bentley and Susan. There's so much you could talk about on both of these talks, and so I'll keep it maybe quick. So when I was thinking about what this is doing, the analogy in my mind is that it's like what happened, like why was finance such an early field that sort of took off with data and machine learning and just ran with it. So data was abundant. It's also an incredibly rapid area, so you get like new data points every 30 seconds. And so, it was able to really take advantage of like reams of data and was sort of always like the cutting edge of what you could do with data and prediction. And now we're sort of starting to build that to the labor market. And what's interesting is also thinking about how like financial economics, there's a great book I like called An Engine, Not a Camera, which is that financial economics didn't just like study financial markets as they were, but was actually actively assisting in creating it. Like Black-Scholes and these equations don't just like price assets that already exist, they enable assets to come into existence. And so this idea that like labor economics might, and I think these tools are sort of pointing in the direction, don't just look like studying the world as it is, they're actually going to wind up constructing new forms of labor markets and new forms of labor contracts. So I have sort of three groups of comments, and we should have made slides. So one is the thing that Susan didn't talk about, but I just kind of love this paper, is this labor LLM paper, which is basically like they have this customized model of career that sort of predicts these occupational transitions using this bespoke, hard to get data set of resumes. But then it turns out you can just ask ChatGPT, give it a sequence of occupations, and ask it to predict the next one, and it does pretty good. And so that suggests there's already a pretty decent model of occupational transitions stored somewhere in all of the stuff that GPT has learned. And so that you're already able to like extract a pretty good model of labor market transitions without having to fine tune on resumes. You need to fine tune a little bit, but there's a lot already there. And I was sort of thinking, why is that the case? And it's partly because in all of the material we've put on the internet, we've talked a lot about jobs and like what occupations are, and they are just cultural objects that we've used to describe different experiences of work and their relationships to people and each other. And so they're like an occupation is like a cultural construct that we've imposed on the world, and you can sort of see, and we might not agree on what this means. So those of you that have looked at this know about ONET, which is a data source that everyone uses to study occupations. It's now used to predict all kinds of things about the future of work. So a project I have with two students that I think are in the audience is basically studying how like ONET actually sometimes it asks a worker and sometimes it asks an expert to assess an occupation. And those two views often diverge. And so like an expert's view of what is an important skill for a job is actually often very different from what a worker thinks the important skills for a job is. So what we all think is like, oh, that's a routine job. There's actually, when you ask a worker, it's not a routine job. Or, and those all kinds of things are. So I think this idea that like what we're learning about the labor market, both in the LLMs, what's the skill credential, these things, they're not just kind of objectively given. They're things that we have to make meaning about. And the concepts we're using have to be constructed and validated, and we might disagree about what they mean. Okay, the second and maybe last point I want to sort of talk about is the extent of the heterogeneity in the labor market. So I was actually sort of, when career gets you to like 0.51 out of sample R squared, I just want to start with like Jacob Mincer in 1958 gets an R squared of like 0.25 with just education and age squared. And so it's just like those three variables get you a ton of the variation in the labor market, and it took career to get us to 0.5, and so there's just like still a ton of unexplained variation in the labor market, and so it means there's still lots of work to do, and it also means that there's just basically some still clear things that we're not able to model very well. And one of the questions is then like, well, what happens when we do make that heterogeneity observable? So, I work a lot on monopsony, and monopsony is basically all about the fact that there's like unobserved heterogeneity and outside options, and employers don't know who's got what outside options, so they lowball the wage, accept some people quitting, but are able to mark down the people that stay. And so when you think about, okay, well, what will happen when we make all of that unobserved heterogeneity and outside options legible, I'm willing to bet, employers are going to get it and HR analytics companies are going to get it before, say, the UI agencies get it. And so they're going to basically be selling and making predictions about what workers' reservation wages are. And so we're just going to see a giant, increase in the various techniques of basically complete price discrimination, which is efficiency improving, so there'll be less unemployment, but it's going to transfer all the surplus to employers or whichever platform is kind of delivering this good. And when you think of the basic economics of like two-sided platforms like LinkedIn, the logic is right, like soak the inelastic side and like transfer it to the elastic side. And if you think that generally workers are much less elastic than employers, then kind of the logic of the kinds of algorithms and tools that are going to get developed on platforms like LinkedIn are basically going to be like, how do we kind of like extract a little bit more from the inelastic side and like subsidize a little bit more the elastic side. And so I'm kind of curious to think about why we think that, for all of these great labor market tools, I'm like very skeptical that the economic forces and political forces at play are going to make it that that government authorities and policymakers are the first ones to use these tools. I think we're first going to get like HR analytics companies using them to like kind of predict reservation wages, and then we're going to see changes in employment happening first in the private sector before policymakers get engaged. So in my last minute, then, I sort of want to talk about the sort of other uses of AI in the labor market. So a lot of what I do is kind of run RCTs with unions, and one of the things that is interesting is trying to leverage kind of, New York City has a law that basically allows any warehouse worker to request their data from the company to sort of measure, to get a sense of like what is the company measuring about me, what's my productivity score, all of these things. But of course, any worker on their own is not going to be able to make sense of this. And so like a kind of RCT we're trying to pilot is how do you kind of solve this coordination or public goods problem so you can get all these workers to simultaneously ask for their data at the same time, and then you can start, when you have a third party that's trusted, kind of like trying to create knowledge for workers themselves about what their employer knows about them, with the kind of idea of producing some form of countervailing power to the HR analytics companies. And I'll leave it at that.
I'll sit down and let me first thank Susan for giving an absolutely splendid lecture in so many ways, and I'll only be able to touch on a couple points. But before getting into the substance, I thought I'd spend just a minute on Ken Arrow, whose this lecture is in honor and a memory of. Ken is probably Columbia Economics Department most distinguished graduate. He got his PhD here. And one of the ideas in behavioral economics is it's really important to have role models. And Ken is in many ways a role model. And for those of you who are PhD students, that's the level that you should aspire to. And you should set that as your standard, that your PhD gets the kind of deserves a Nobel Prize. So that's, I'll just make it clear, that's what we expect of all of you. He was one of the greatest economists of the 20th century. He was my teacher in the fall of 1966, just a few years ago. And we became good friends with shared interests and values, especially after I went to Stanford and we saw just a lot of each other. One of the reasons we were, another reason we wanted to have a series in his honor and memory was he did work in every aspect of economics. And that's what's so great about having a lecture series, because you can have a lecture in health economics, in technological change, in labor economics. He did work in both education, and he was very interested in one of the issues that Susan talked about, discrimination. That he focused more on racial discrimination, but the general theory of discrimination was one of his important contributions. So again, in terms of one of the problems in the economics profession has been that people gotten narrower and narrower. Susan has shown that you can still say broad. I thought she was going to talk about more on market power, where she's devoted her time for the last several years. But this has been absolutely fascinating, and obviously very, very appropriate for one of the major issues that we are all facing in the coming decades. The topic, the talk, is one I think that Ken would have loved. It combines big methodological advances with the application to a set of critical importance. The first one, I'll comment a little bit more, that she talks about is the effect of job displacement when you lose your jobs. And it was a problem that first came to a widespread attention about a little over 30 years ago, when in the aftermath of the 1991 economic downturn, there was a New York Times series that discussed how the articles appeared in 93, 94, 95, that it began to be uncovered that losing a job has an effect not just at the moment, but for a long time afterwards. That there are long-term effects that seem to persist. And the question was, what are the causes? Very different from our standard model, particularly in macroeconomics, where people lose a job and they just move somewhere else, perfect labor market. These numbers, these figures show very strongly that when you lose a job, I mean, everybody knows that it has a big effect, but macroeconomics has seemed to ignore that, and this gives micro foundations telling us that these effects are very big and can't be ignored, and they're just. And the question then is, what should be done? When we have had these series for the first decade, Ken Arrow came every year and commented on the papers, and it's sad that he can't be here. But also, Bob Solow used to come very often. And Bob Solow this was one of the questions that he was very interested in. And he chaired the board of a nonprofit called MDRC. I can't remember exactly what it stands for, but what MDRC did was to do experiments. It was one of the early examples of experiments in precisely the issues that Susan was interested in. What interventions will have what effects in the labor market? And so it was before a lot of the sophisticated econometrics that we have today, but it was a clear, real example of experimental economics. The import of the kind of work that Susan does has been doing is that if we can target better who really needs intervention. And if we can think of where the interventions are likely to be most effective, we can get much better at interventions at lower costs. And given the magnitude of the effects that are described in terms of lifetime losses of income, that can make a very big difference. Hysteresis matters, the effects of job history matter, and if we can change those job history, shorten the time that people are in unemployment or where they have to take a much poorer job, it can make a real difference. And that's why ideas about how you can get people, how you can reduce the information frictions are so important. I want to just, since I have only a little bit more than a minute left, I want to mention 3 ideas related to artificial intelligence more that are more broad. The first is the existence of deep uncertainty, the idea that there are events like the financial crisis of 2008, COVID-19, or what's happening now with Trump, are events that have no precedence. And so you wonder at how, by looking at the past, which is what any model does, can provide a prediction of the future. Now, the AI optimists begin by saying, but look at, when we're making our judgments, we're also looking at the past. We're filtering that information somehow, and if Bentley is right, these things are going to be so much smarter in filtering the information better than we can that all of us are going to be unemployed. It's not going to happen in my lifetime, I don't think. That's the good news, and I don't think it's going to happen in the lifetime of most of you. But it is there is an idea here that all of us can only make forecasts on the basis of past. But the way we make those forecasts is based on more structural models, and AI will eventually maybe get to those more structural models, but I think it'll be a little while. And then the second thing I wanted to comment on AI relates a little bit to what Suresh talked about. AI does allow better price discrimination, and the question is, whether that's a good or bad thing. The fundamental theorems of welfare economics that we all sort of intuitively use in our back of our minds, the efficiency of the market, the invisible hand, are based on the assumption that everybody faces the same prices. And price discrimination is the opposite of that. Now, while it's true that with perfect price discrimination, you can get to a first best. The world is not based, will be a long time before we're at perfect price discrimination, if we are ever there. And imperfect price discrimination is, in general, worse than the outcomes of the first fundamental theorem of welfare economics. So things may get worse in the next million years before they get better. And the final thing is a two-sided thing about both good and bad. One of the concerns I have of AI is that it is getting better at pollution, polluting the information ecosystem with mis and disinformation. Now, it's also getting better at detecting mis and disinformation. So there's a war going on in which the information ecosystem is increasingly polluted. Those of us who don't have tools those who don't have tools for extracting all that garbage are facing a harder and harder time. Where this is going to wind up, I don't think is yet clear. But in the meantime, I think there are a lot of jobs for ordinary individuals to try to, on the one hand, extract truth out of the garbage that is out there, and secondly, to help design regulations that will reduce the extent to which AI can impose harms on the rest of our society. Thank you.
So I think I was supposed to react briefly, and thank you so much for these wonderful comments. And I just wanted to highlight a quick thing or two. I think both Bentley and Joe's call were really like calls to action on research topics, which, and I'm going to come back to Suresh also, but you had one of the things that both of you, I think, really focused on is the fact that in these changes, workers are going to have to make transitions. And we are not very good at helping workers make transitions. In fact, as Joe pointed out, we didn't really identify it as a problem for a long time. So that was really the motivation for these two experiments that I ran. And I hope that they're contributing, but I think we have a long way to go. So that's a big motivation there. Just on the market power point, just connecting Joe and Suresh, I completely agree that it is just fascinating what AI is going to do to market power. I do have a little bit of work started in that direction. It's a big, hard problem. And I've been trying to think about how to connect the work that I've been doing to labor market monopsony. Because exactly as you said, I'm so glad that you pointed that out, that when you see heterogeneous impacts of job losses, that also shows that there's an opportunity for monopsony power. And it is concerning to me as well. And also just AI in general, price discrimination. When I was at the Department of Justice, we brought a case against RealPage, which had algorithms for setting rental prices. There's a lot of really interesting open questions around how this is going to change the economy. So, but with that, let's go to Q&A. And actually, I didn't ask. Am I leading Q&A? Well, anyways, someone. How are we doing Q&A? Yeah, Ken.
We'll bring the mics around.
Okay, so raise your hand and mics will come.
So let me ask a question. I mean, I thought it was fascinating what you talked about at the end of the talk about the career model and how one could look at complicated aspects of histories to forecast better. A question about that, I mean, there are lots of areas of application where we would like to forecast better and where there are in principle complicated histories, but how large a data set does one need to have available to train this kind of model for this foundation model approach to, in fact, help us do better than the kinds of regression models with small numbers of regressors that we're used to doing?
Yeah, so actually I should have slowed down a little more on the point that one thing that's really special about job histories, it's a discrete choice model, basically. So if it was just a sequence of numbers, that's much easier to fit. It's the fact that it's 330 job ones and 330 job twos and so on. That's what creates the explosive problem. And that's why the very most recent machine learning methods have so much benefit, because the architecture of the transformer models that was designed for language are really good at getting these sequences of discrete choices. And so that's one place where the transformer models work really well. We had the 23 million resumes, but actually you could do with a fair bit less. And then, as Suresh mentioned, in my most recent paper, we actually used the text model itself is the foundation model, and then we only use the public government data sets to do the fine tuning. So you can think if you start from Llama, which is what we did, then you can work with a very small data set. So I think that's part of the promise. And this only has value if your data does have information in it that's sort of captured by text in that case. So we actually do an experiment where we train the model, we fine-tune the model with sequences of job titles in text, and then we fine-tune it with just numeric job codes. And it does much better when we put in the text, which is just showing it's not just having like a rich, fancy neural network. It's the fact that the llama is encoding information about the words carry information about two jobs being similar. Electrical engineer, software engineer are similar. So yeah, I think I've also thought about this a bit. What are the other things that have that flavor where they're economic prediction problems, but they're kind of just discrete choices with a lot of choices? Usually in economics, we just collapse those. Like you're working, you're not working. Or, you know, you're taking care of kids, or you're working, or you're part-time. You know, we just collapse the history. So we have to kind of go back and think. All those government surveys, those were actually like, there was text, people talked. There's like, you know, you could actually do a lot more if you anticipated modeling in this way. But I think for like just pure macro forecasting of numeric variables, neural nets have been helpful there too, but I think the delta is not as large because we already had worked pretty hard to find functional forms that fit the numbers.
Mike, can I make one quick comment? Yeah, so one thing just to follow up a little bit, I think Joe was mentioning our students here. I just want to remind students that that Susan's work on the Swedish data actually follows up some work done by one of our graduate students, Johanna Schmeider, who's at BU, who's actually one of my students, who did some of the original work on these shocks, which is quite good. And I also mentioned another Columbia student, so I think is actually Mika Sviacci, who just got tenure at Princeton. And one of the things, and the reason I mentioned her is that what she did was to look at how a person's early career, in particular whether or not they're involved in the drug trade in Peru, would actually affect whether or not they were incarcerated later on. And so both of them, who are Columbia graduates, were sort of in the Minster tradition of looking how these early, these later market shocks, and I think Mika's work is particularly interesting. I like to see more along those lines, which is looking at, 10 or 15-year horizons on looking at this history affects the future. And I think it's really important work. And I think the technology that Susan's describing has some potential to look at some really hard and important questions. So I just remind you, and this has been done at Columbia, and I'm sure all of you can do more.
Can I just add one more thing? The importance of Susan's work. It used to be thought when I was on the Council of Economic Advisors, we were very depressed. We knew that on the one hand, the displacement mattered, but the common wisdom was the active labor market policies didn't work. And so, we were sort of in paralysis, and that's why it's so important figuring out how to target and how to design better policies and how to test which policies are working, and so that kind of these tools become really important. But now we know that there are policies that will work on certain groups of people, and so the fact that they might not work on average, if you don't target them right, doesn't address the question of can we design a medicine that works on those who are most badly affected.
And so my presidential address is about to come out in the AER, and I actually go in some link there about the product design process, and that was really kind of an inspiration for these, instead of, again, just saying, okay, the literature says nothing works, so I guess nothing works. Instead, actually go talk to the people and, I helped women going into IT in Poland, and maybe that's small, but it's a case study that then kind of tells you about mechanisms and invites further exploration. Okay, we have a question.
Hi. So the canonical production function in econ has human capital as like the input, right? But there's actually in AI now like agentic AIs that can do the jobs of humans. Like there's AIs that can do customer service. So what are your thoughts in a world where AI actually fully replaces labor?
Yeah. So, I mean, so there are, I think there's like a panel a week on this topic, so I can try to like channel all of that. But no, it's, I think first of all, we have to think about general equilibrium economics to answer that. And so, I mean, I go to a lot of computer science conferences where the computer scientists are like, okay, great. Technically, you know, we can do A, B, and C, and I think we'll be able to do D, E, and F in 5 years. So therefore, we need to plan for all of us sitting on the beach and having drones like, you know, drop, you know, daiquiris to us. And it's like where to start with what's wrong with that vision. Okay, first of all, like, you know, banks have there are tens of thousands of people around New York probably that just copy things from one database to another as their job. And you ask, why is that? It's not that we don't have the technology to automate that today, but there are other frictions that get in the way. And so it's going to take a long time for us to remove those other frictions. If you think about having every problem solved on your phone, well, what does your phone want? And actually, like, do Apple and Google want ChatGPT's agent to, like, take over the phone? Like, probably not. So there's a lot of economic considerations that affect the pace of adoption that aren't part of the technology. A second thing is that, you know, what's going to make everybody drop daiquiris on the beach? Who's dropping them, actually? And why are they dropping them, exactly? And are they dropping them on U.S. beaches or global beaches? And, you know, why does it matter that we're all happy? In a world where AI is so good, it also can support autocracy and, you know, fight wars. And so, you know, it's not clear why we're all going to be sipping our daiquiris. So I think, so that's like why, you know, utopia seems unlikely. You know, complete dystopia also has some negativity to throw on it in the sense that we have, you know, so many frictions along the way to actually fully implement technology to replace all of us. And then, you know, if workers get cheap, then maybe people will still hire workers. They just, because there's still something productive for them to do, they just won't pay them very much. And, you know, there's a question of if somebody does or doesn't decide they want to send them a daiquiri. So, but bottom line is that, you know, these future predictions they actually don't make a lot of sense without thinking about the economic general equilibrium, how wages change, how firms' investment changes, how governments change. They're very hard to sort out. One other thing, just coming back to the market power point that I've been pushing in a lot of my talks is that, you know, it does matter what the market power is if we have low markups on, if good production gets if workers' wages fall and we don't need a lot of workers, then in principle, goods production could get cheap and then goods could be cheap too. But that requires not some competition in the people who are selling us things. And if we don't have that competition, if any place in the supply chain, somebody's got a competitive bottleneck, they can extract surplus, which, you know, means that we may have more trouble. So all pretty, you know, we could have a whole conference on this or many conferences on this. There's theory that work, there's empirical work, but in the short term, I think thinking about transitions, this is going to be a hard transition, and we're so good at crises. We've seen this lately. We're so good at pulling together as a society and not letting it divide us. And these crises will be bigger than some of the crises that we've had in the past. And so, you know, trying to figure out, even like having people be unhappy for 5 years might be 5 years too many in the context of global politics and so on.
So with that optimistic note, I've been told if you turn around, you can see a big sign, Joe, please close the event. So I'm a human robot. I do what I'm told. And this has been absolutely fascinating, and as Susan said, there is huge lots to discuss on all the topics that have been raised this evening. And I hope we can get Susan back again to talk more about AI, monopoly power, the transition, the politics behind this, because it's clear that AI is a powerful tool. We've seen how it can increase the knowledge that we have, make us do a better job at what we do. But it does present some real challenges going forward. So let me thank you again, Susan, for a wonderful talk.